Give me some time. I'm coming there. Okay, just wait for it. Oh, okay. Sorry. I'm back once again. Just give me a moment. I'm just joining these things. Right. I have not shared my slide. Just a minute. Okay. So let us begin with one more problem on rotation. Surface density in rotation. Okay. Problem on integration. So probably our 9th and 10th standard students may not be able to get it so quickly, but definitely it's a cup of tea for JE mains and 11th and 12th standard students. Okay. This is basically a JE mains problems. Bit complicated problem, not so easy to do. But anyway, it doesn't stop from saying, okay, the other students cannot do it. You can also try doing it. So the surface density is nothing but the mass by area of a circular disk of radius A depends on the distance from the center as rho of r equal to A plus Br. What does it tell? It tells you that you have a disk, and then in this disk from the center, see the mass here is little, here it is little. Now as we keep on going, the density keeps on increasing. Mass density keeps on increasing. As we go away from here, that's what it tells you. Okay, when we go away from here, density keeps on increasing from the radius, and the way how it is increasing, if you ask me, then this is given by rho of r equal to A plus Br. That means initially density is constant at r equal to 0. At r equal to 0, put r equal to 0 here, then I get rho of r equal to A, which means some material over here, so which is present, light material. Okay, it is like taking up a disk. Say for example, disk. I have a disk over here. I take up a disk over here, and at this region, there's a lesser density. But as I keep on moving away, the density keeps on increasing, which means that more number of particles are here. Okay, maybe it becomes more thicker and thicker, something like this. Just imagine. Okay, now we have got the disk. Find its moment of inertia about the line perpendicular to the plane of disk. Now, this is the plane of the disk, and this is the line that I have drawn perpendicular to the plane through its center. That's been asked. A very similar question. Now let us see. Surface density is given by mass by area, which is m divided by pi r square. Why m by pi r square? Area. What is area? Area of the disk. Okay. So it is not dependent on density. Circular disk means anyway it's fine. R is the radius, so I get this value. Moment of inertia is given by the formula integral of dm into r square. What is r? R is nothing but the distance from the center, from the axis to this point. This is what it is. So therefore, now what I will do is I'll write dm should be equal to rho of r into pi r square. What is dm? So dm, mass dm, should be equal to density of the disk multiplied by pi r square. What is pi r square? The area of the disk. Let us say, for example, I consider a small disk nearby over here. Okay, and I ask what is the mass of this disk. Okay, I have not taken the full disk, small disk over here. Okay, let the radius, the complete radius, this full radius starting from here to here, let it be capital R. Okay, this small r is referred to this one. Okay, so therefore, so this mass is nothing but this density multiplied by pi r square. We can do it like this. Now, this is what he has done, and he substitutes it over here and get the answer. So towards it, now the answer that he gets is that moment of inertia I is equal to rho of r. What is rho of r? A plus Br integral 0 to r, because I'm integrating from 0 to r, from the initial point to final point, into pi r square into r square into dr. So what do I get here? I get the answer as, let me write it here, which should now be equal to a integral of 0 to r of pi r power 4 dr plus, I'm just expanding, nothing else, plus b is a constant. I'll remove this. B pi. I missed this. Okay, let me put pi outside, pi inside. Pi is also a constant. I would have removed it. Maybe I will remove it here. I'll remove here. Pi is a constant. And here also I'll write pi b. I'll remove it here also. And then I have r square, there's one more r, which is r power 5 into dr. So thus I will get the answer as a pi into r power 5 divided by 5 plus r power 6 divided by 6 plus b pi r power 6 divided by 6. This is the answer we get. Now, is this correct or wrong? That's what we need to look at. Definitely this is incorrect. Why is this incorrect, and why did the student make a mistake like this? Though his approach was almost right. Integration is correct, no issues at all. But the problem lies over here, the mass that he has considered. Let us understand what is the problem over here. Now, when I call about the density dm, and I write this pi r square, now how did I get this value of dr here? See, in any integration problem, see here, it was only dm here. Okay, what did the student do? He substituted this value. When you substitute this value for dm, this equation is correct. Until here, it's correct. So what is that you should get? You should get an answer saying that moment of inertia I is equal to rho of r pi r square into r square. But to integrate it, I should get something which is dr over here. This is missing. The moment you recognize that this is missing, that means something is going wrong. Okay, so you should identify that. That's the first thing. So therefore, your way of doing things is incorrect. That's what we should do. Now, how should we solve this problem? The solution lies like this. Okay, this is an incorrect solution. Let us do the right one, the correct one. Now, so how do you do the correct one? The correct one is being done like this. So now let us consider a disk of radius r, which is at a distance, and then let the thickness of this disk be dr. Because every time as I keep on going, okay, the surface density is increasing, which means more number of particles are being stuffed. It is not going to be a uniform disk, right? It is going to be a disk which is like this, right? So which is something like here it is depressed, and here you are going to get like this over here. So the thickness will now keep on varying. So as a result of it, this is incorrect, right? So you cannot have the uniform surface over here. So you should have something like this. The mass will increase with thickness. So that's what we need to do is we should take the circumference. I should take the circumference over here. Circumference multiplied by the thickness, right? So therefore, the area the mass will now be equal to rho of r, and this will not be pi r square, but instead this will be 2 pi r into dr. See how essential it is to understand things. Okay, it is not so easy. Physics, if you want to solve problems in physics, the first thing that you should know is you should have a good imagination skill. Okay, until unless your imagination skills are poor, your visualization skills are poor. The moment I say a disk comes to my eyes, I just imagine a disk is before me, and this is the way how it looks like. Okay, it's very, very important. So until unless that doesn't come to your mind, every physics problem would be very tough. So initially, if you want to solve such problem, because it comes only by practice. So what you do is you need to make models and then understand how does it work. Okay. Shortly, I will be introducing a course in physics which involves learning physics using simulations. This might be coming out in the month of January. I'll be showing you a software, and in that software, okay, so you will be simulating every problem. I will be simulating every problem. I'll give you access to it also. Of course, it's not free because I have to pay and you also need to pay. Okay. This is aimed in teaching physics for students who are really interested. Okay. So don't consider this from your marks point of view. If you consider from marks point of view, I am not the right person to teach this. Because if it is from marks, you need to mug up something, which I'm not going to do this. Okay. Right. Now let us solve this problem. Now this dm is given like this. And then I'm going to write this moment of inertia to be equal to, let me substitute here. So now dm, where is dm here? I'm going to substitute here, dm. I'm not looking at this. So this should be rho of r into 2 pi r into r square. Where do you get the r square? This r square into dr. Now let us solve this. Now what is rho of r? Rho of r is nothing but A plus Br. into 2 pi into r cube into dr. Now, when I have an integration, I should have limits 0 to r. So, which should now be equal to 2 pi into a into integral of 0 to r. What do I have? R cube dr plus b into integral of 0 to r. Now you have br here. R into r cube will be r power 4 into dr. Wow. Now I think my work becomes much more easier. So this should now be 2 pi a. R cube is nothing but r power 4 by 4. R power 4 by 4 plus 2 pi b. 2 pi b. And what is this now? R power 4, which should now be equal to r power 5 divided by 4. Now what I will write? I will write this as, I'll take common 2 pi outside and I will write this as, I think I can also take r power 4 common, a divided by 4 plus br divided by 5. Right? So this is the correct answer for this. 2 pi r power 4 into a by 4 plus br by 5. So finally, we end up with this solution for this. I hope you have understood the solution behind this, as how to work on it, and where was the misconception. The misconception was in writing down the surface density. Okay, so generally surface density means it is just mass by area. Okay, so here you need to be very careful about writing the mass dm. In any integration, when you do substitution, now what you should get is, when you do the substitution, the variable corresponding to that should have the differential value. What do you mean by differential value? The dx, dy. Okay, when you substituted something, you substituted m for x. Okay, you wrote something like m in terms of x, m in terms of r, and so on. At the end, you are describing mass in terms of radius, mass in terms of distances, and so on. So if m is varying, x should also vary. If m is represented as dm, then the next variable that you have put across should also be represented as dx. Okay, if that is possible, then your integration is correct. Else, you will land into a problem. So with this, let me stop over here. In the next video, we will see some more information on torque, moment of inertia calculations. Okay, what are the several types of misconceptions one we do get, and we'll continue with this chapter. Okay, thank you friends for watching, and if you like this video, do share and subscribe to my channel for more such updates. Thank you.